Hey guys, welcome. Let's go ahead and get started on 1.3, angle relationships. Alright, so our first one is angle bisector, which is basically a ray that divides an angle into two congruent, again congruent means the same shape or size, angles. Okay. So we can see here in the diagram to the right, BD is our ray. So we have ray BD coming right here. And that's going towards D indefinitely. Is an angle bisector. Therefore, we can state that angle, and this angle right here, ABD, is congruent to this angle here, angle DBC. Again, D is that vertex right there. So DBC is this guy right here, and we have ABD is this guy right here. So an angle bisector, basically we want to remember it's going to cut it in half. Cuts in half, okay, to two congruent pieces. Perpendicular lines, they intersect at a right angle, okay? So that's our key, right angle. We can see right here, this is our notation for a right angle, that little box guy, right angle. And our symbol for perpendicular is a little, looks like upside down T, makes it kind of looks like it's perpendicular. So in the diagram to the right, we could say that line L is perpendicular to M. Okay, so perpendicular. Perpendicular bisector is a line, segment, or ray that is perpendicular, as we might suppose, and it also is a midpoint, so it bisects it. Okay, so in the diagram to the right, we have LM is the perpendicular bisector to segment PQ. And here we can see that we have our midpoint is established by the dot. Because we have these two pieces are congruent, we know that that little point is in the middle. And then we also know that it's perpendicular because we got our little 90 right there. Okay? All right. Again, we're going to try and hit some examples more so in class than during our notes. So, angle addition postulate. So lots of vocabulary that has a lot of meanings and implications for us to set up equations and get understanding. So angle addition postulate, we saw segment addition postulate, which was a little piece plus a little piece equals a whole piece. And so same thing here, angle addition postulate is two little angles added to make a bigger angle. So if D is in the interior of ABC, so D is a point inside this angle, then we can say that the measure of ABD plus the measure of DBC is equal to the measure of ABC. And let's use some highlighters to help us out with that. So that I'm saying basically that this angle right here, ABD in yellow, I take that and I add it to the measure of DBC, which happens to be this angle right here, those two little angles. It should add up to the entire angle of ABC. And that seems to be pretty logical. That's why we call it a postulate. It means we don't need to prove that two little things add up to make a bigger thing. It's pretty much well established that we don't really have to do a lot of extra work to prove that. Okay? So we're going to see some examples here that we'll see in class. We're just basically adding angles up together, which isn't super gnarly. I am going to do one of these from before, just for fun. But we have ABF, so it's good to kind of identify where your angle is. So ABF is this guy right here. And I like to go ahead and put the angle measure inside 6x plus 26. And then EBF right there is this guy, and he is 2x minus 9, and then ABE, now ABE looks like it's the whole thing, and that is 11x minus 31. And so as we can see here, we're getting into the situation of I have little angle, set equal to the big angle. And so that's what we want to do. Visually I can see that. That's why the highlighters are so helpful. We want to find ABF eventually, which means I have to solve for x first, and then I can plug it back in. So we're going to take that 6x plus 26, so that little piece plus this piece, and we're going to set it equal to the entire thing, 11x minus 31. And again, we're using algebra here, so a lot of things are variables, so we don't really, kind of sometimes it confuses students, but we know this plus this will equal this based upon our image. So we can combine like terms. 6x and 2x is going to give me 8x. 26 minus 9 should give me 17. I'm just going to double check with my calculator that I don't make a mistake on that, but I'm good. We get 11x minus 31. Now we want to move. Again, 8x is smaller, so I'm going to move the smaller one over. While I'm doing that, since I'm moving the x over here, I'm going to move the 31 over here. So 17 plus 31 should give me 48, and 11 minus 8 should give me 3x. When I divide by 3, x is going to give me my final answer of 16. Now that's not my final answer because it said find ABF. Okay, so to find ABF, I just got to plug it back into ABF, which is 6 times, in this case that's 16, so 6 times 16, and then we just kind of add the 26 to it. I'm just doing all this kind of in my calculator. So the measure of angle ABF should equal 122 from right there, and that's our final answer. Okay, so again, we're going to use concepts of angle addition postulate, midpoint, bisectors, all that good stuff. Okay, all right. Next, we have some more angle relationships, complementary and supplementary. So complementary angles are angles that will sum up to 90 degrees. And a good image for that would be something like this, where it looks like we have a 90 and then some angle in there. And it just says that the measure of angle 1 plus the measure of angle 2 should equal 90 degrees. And then conversely, we have supplementary, which is 180. And supplementary don't always, again, notice we don't have to be actually sharing the same vertex. Like this one has different vertex that does share. So complementary and supplementary don't have to be sharing a vertex. So this would be 135, this could be 45, and we know that 135 plus 45 would equal 180, so that checks off. And so those are complementary and supplementary. Now the way I kind of remember is complementary starts with a C, supplementary starts with an S. C comes before S, that means 90 comes before 180, so it kind of helps me remember complementary adds to 90, supplementary adds to 180. Okay? From there we have adjacent angles, so those are two angles that are next to each other and they share a common side. So we would go ahead and say these two are adjacent, so angle 1 is adjacent to angle 2. And the reason why is because they're next to, they share a common side right there. Those two angles share that common side. Vertical angles are two angles across from each other and on intersecting lines, and they're always congruent. So if I had 1, 2, 3, 4, I would say angle 1 is congruent to angle 3, and I'd say angle 2 is congruent to angle 4. So basically we would say our opposite angles are congruent in this diagram. And those are vertical angles. Again, notice that if we know something's congruent, that's going to help us set up an equation. Now, linear pair seems very similar to supplementary. The big difference between these, and this is why we kind of drew this one like this, these ones don't have to be next to each other. These have to be next to each other. So the measure of angle 1 plus the measure of angle 2 should equal 180. And the key here is that they are adjacent, meaning they share that common side, that common vertex, and they also have to form a straight line right here, which these do. This doesn't form a straight line. There's a little gap, so not quite a straight line. Okay. All right, and then if we flip to the back, we basically just have a lot of examples, and so we're going to actually just go ahead and wait on those to do in class. So there you go. That's our vocabulary.